This is problem 123 from chapter 6. In the problem, we're told we've got 1.51 grams of potassium, and I'm going to go ahead and convert that to moles because that's going to be handy later on. So I'm going to use the molar mass, and when I do that calculation, I get 3.8619 times 10 to the negative 2 moles of potassium. Now I'm ignoring sig figs for now. I'm just keeping lots of digits because I'm going to round when I get to the end. So a couple of things I know from the problem and I know from chemistry here, that the moles of potassium bromide plus the moles of potassium iodide are also going to be equal to the moles of potassium. And that's kind of the key connection that you've got to make in order to solve it this way. Now there's more than one way to solve this problem, and some of you have done it differently. I'm going to make those variables x and y. So moles of KBr is x, and moles of Ki is y. I also know from the problem that the mass of potassium bromide and the mass of potassium iodide is equal to 5 grams. I also know, just because I'm going to need this information, I've got to find the molar mass of KBr, and that's 119 grams per mole. I need the molar mass of Ki, and that's 166 grams per mole. So I'm going to take the equation of mass of KBr and mass of Ki equals 5 grams, and I'm going to rewrite it a little bit. If I know the moles of KBr and can multiply that by its molar mass, well, that would give me a mass of KBr. And the same thing with potassium iodide. If I know how many moles of potassium iodide I have, and I multiply that by the molar mass, I'm going to get the mass of potassium iodide. And those two things added together should equal 5 grams. Now, if you remember the other equation, I called moles of KBr x, so I'm going to make that x in this equation as well. And I called moles of potassium iodide y, so I'm going to make that y in this equation. So I'm kind of building two equations now and two unknowns. So here's that other equation that I had on the previous page, that moles of potassium bromide plus moles of potassium iodide was equal to 3.8619 times 10 to the minus 2. All right, so I've got this equation. I've got this green equation down here, and that's one of the equations. And I've got the red equation up here. That's the second equation. So two equations, two unknowns. I can solve that with algebra. So when I do the algebra and solve for x, and I'm going to assume that you can do that. I'm not going to walk through every step of that. I find that x is 3.0017 times 10 to the minus 2 moles of potassium bromide. And y is 8.6021 times 10 to the minus 3 moles of potassium iodide. I am then going to convert those to grams. And when I do, I get 1.428 grams of potassium iodide and 3.572 grams of potassium bromide. Now I use the molar mass to make those conversions, and now I just calculate the percent by mass with the 1.428 grams of potassium iodide per 5 grams of the mixture. Multiply by 100, of course, and I get 28.6%. And then the same process for potassium bromide, just using the mass of potassium bromide, 3.572 grams per 5 grams of the mixture, times 100, and I get 71.4%. This was a tough one. I hope you found it helpful. Feel free to ask questions next time you see me in class.